shall we continue? Okay, Assalamualaikum and very good afternoon. This afternoon we will continue to have module 2 design. So this morning you have learned about the statistical method in using ANOVA and all those things. And then this afternoon we will like to focus more on how to use the DOE design and experiment. Okay. So this is our course of content. Number one is introduction and ice breaking. Secondly, the learning outcome. Thirdly, introduction, how to design your model, your experiment. Fourth, on design experiment software introduction, and I will touch a bit on the single factor experiment, multiple levels, full factorial design, followed by fractional factorial design, and also some exercise for DOE. We will have a helicopter design exercise after this, maybe after the break, and then summary and review outcome, Q&A. Okay. Okay. My name is Fadhli Hadana from CCUS department. Joined PRSP in 2009. I'm doing gasification project in early 2009, and also cryogenic dispersion project back in 2015. We have some collaboration with some oil and gas companies like Total and all those things. And then now I'm doing this scribing project. If you have heard about scribing project, okay, that's all about me. Any questions so far about the trainer? If not, maybe some ice breaking or introduction. I would like to know maybe your some briefly over your name, department, maybe some projects. Is it okay? Although I've known some of you. Okay, maybe Tarus. MBC. Okay. So normally, what kind of experiment that you do in MBC? Okay. Do you have any some factors, number of factors you test? Okay. So do you have you heard about DOE's or experience to use this software before? Okay, good. Okay, next. Thank you, Cyrus. Mama Aidil. Okay. So in your project, do you have any experiment to be done? Tak ada. Some factors you want to identify or some testing?
Yes, so I described it right now.
Okay, that's good. Thanks.
Assalamualaikum, my name is Muhammad Saifuddin. I'm from SCT department. I'm currently working on project with biopolymer.
Okay. We also some experiment for.
So usually for biopolymer, we need to synthesize this polymer using the fermentation process. So basically, we need to consider all the parameters, the pH, temperature, and also the carbon source. That this need to be optimized
controversial lah. Okay, thank you. Saifuddin. Okay, next. Soraya. Salam. Project. MBC. Oh, sama dengan Tyrus lah. Okay. Pernah juga DOE before? I think we will learn how to get the optimum condition lah. Mungkin we have some range of data or something, then we can narrow down to what is the optimum condition lah by using this nanti Innova atau apa semua. Next. Awin ya. Projek apa sekarang nampak? Pernah guna this DOE software before? Thank you. Ke belakang.
Assalamualaikum.
Salam.
Saya Syahrul,
Syahrul.
AMST, Robotic Automation. Currently working on the project network server, robotic automation.
Okay, pernah guna DOE software sebelum ni?
Dengan tu data analytic.
Okay. Okay, thank you.
Assalamualaikum, Ashira from ANST. Current project photography.
Okay.
Yeah.
So, how about the design of experiment? Have you done before?
No.
Is composition of a mix of coke and graphene or something?
Kalau yang tu sebab sekarang pun delivery, so macam untuk design of experiment saya tu more untuk study punya scope lah. Adalah a few tapi tak too detailkan guna software and everything.
Okay. Alright. Okay, nanti kita learn about this software. Okay, we continue next. Okay, next on the learning outcome. So at the end of this training, learners will be able to first maybe to understand the DOE model, design of experiment model, how to choose the model, and then we'll talk about the single factor experiment, full factorial, and fractional. So why we need to have full factorial, why we need to have fractional. We'll talk about this more. And secondly, we will able to utilize the DOE software, design expert software, properly. Thirdly, we can apply the design of software, design expert software for the given case study. In this case, we will have helicopter flying time. Maybe after the break, we will have this case study. And then without referring to manuals, so you will have hands-on lah later on for this. So these three are our learning outcomes. Okay, next. How to design your model. Normally, in this case, we will have some parameters like pressure, or temperature, or flow rate, or all those things. So we don't know where is the optimum condition. So in DOE, the first screening method that we have, we can have two levels, maybe the minimum point and the maximum point. And at that time, we run one case, and then we can gauge where is the optimum point. After that, we can have another after screening, we can get another experiment to get the very optimum point lah for this experiment. Okay. So design a matrix for full factorial, and normally offered as one factor at a time. If we have two factor like factor n and factor b, and two level minimum and maximum. So at the end we will have 4 experiments. So in here we have two power of 2 is for experiment. But if you have three factor, like maybe pressure, temperature, and CO2 composition, then ultimately we will have A experiment. Okay, you get it? Okay, after that, if the number of factors increasing, like 2, 3, 4 up to 7, and if we have 7 factor, and then the experiment will be increased. The number of experiment will be increased up to 128 experiment that we have to conduct. This one does not include the replication yet, because this morning you have learned about this replication, improve the p value, sorry, to get a p value less than 0.05, right? Okay, that brings up to the higher cost lah. If you do this, increasing number of experiments, meaning bringing more cost. So this is the methodology that we have learned. First, should you define the problem? What are the problem currently? If you want to achieve more yield or optimum condition, operating condition, you should define first. Secondly, set the objective. What is your goals for this experiment? In finding what? And then determine the factors. Factors, what are the critical factors? Let's say in our experiment, maybe the starting material, the pressure, temperature, and all those things. And then after that, what we can do is determine the response, what result or what yield that you want to have. Maybe higher flying time or a good taste of a cake or what. And after that, then you can design the experiment, DOE lah. This DOE. And then conduct the experiment and data collection. You input the data in the software, and also analyze the data using this software. You can do interpretation of data and confirm the model. So these are the methodology that we want to conduct using this DOE software. Any questions so far? Maybe later I will share the slide lah, for your reference. Okay, this is maybe I just quick because I have another about 90 slides. The main maybe you can finish up to 6. It's okay. Okay, so maybe I can skip some of the slide lah. Okay, because the main is maybe to use the software and also to practice lah. This one just a bit of theory. Maybe some of the slide I will skip. This one just to show what are the factors and responses. So let's say in field building and chemical process and digital imaging, what you want to see is the speed, contrast, yield, purity, image resolution, and all those things. The factors can be silver laydown, finishing time, catalyst, transport speed, and capture length. Okay, in doing this, making a cake, there are some factors like oven, sugar, flour, eggs. These are our factors, 4 factors. So the levels, we can have 2 levels. Maybe setting at temperature, 2 temperature, maybe minimum temperature and higher temperature, maybe 120 and 180. You see what is the difference? And then sugar, maybe 1 cup or 2 cups, minimum and maximum. Flour, maybe 1 scoop or 2 scoop. Eggs, maybe 3 or 5 eggs in 1 cake. So what we want to outcomes, example of characteristics like taste of the cake, color of the cake, and also consistency, the taste consistency. So these are the response that we want to have in the software. Okay, I think similar to this as well. This one okay, replicate and blocking. Why we need to replicate? I think this morning Gun already and Derek already mentioned about replicate and blocking. So in replication, we need to increase the number of p value, and so that the model is significant. So we are targeting the p value is more than less than 0.05. So if you see this model, no replication, they have about 32 experiment, but no replication. End up the model is not significant. You see the p-value is 0.76, and the model is not significant. So that's why we need replication to reduce the p-value numbers and to make the model significant, meaning the number of errors is less than 0.05. So blocking just now, this morning already touched, right? Why we need some blocking? Because maybe day and night shift is different. Temperature at night a bit colder than at daytime. So we need to do some blocking. We don't want this environment affect our results later on. So that's why we need some blocking. And also operating panel personnel, night shift and day shift is different. So we want to avoid this. We need to do some blocking. So in blocking, I think this one also is true. We will see later in the software. This one on the factorial, I think just to show, if you have 5 factors and 2 levels, so the number of runs is 2 times 2 times 2 times 2 times 2 is total is 32 runs. This one without replication. If you want to have 2 replication, then 1 replication, meaning that you have to run 64 runs of experiment. But we don't have much time. Maybe our boss say, I want this result maybe next week. So how come you can get 64 runs within next week? Maybe we will have some, instead of full factorial, we can change to fractional factorial to reduce the number of experiment and maintaining the same quality of results. Okay, this one I think later we will talk about fractional and full and fractional factorial. Compounding effect, this one later. Okay, have you installed anybody successful to install? How many person? Ada Syahrul Syahrul, Suraya, Iris, banyak juga. Okay, yang not available masih lagi? Dah, okay, dah. Oh, semua dah lah. Okay, good. So maybe we can have a look on the design expert software. So we can open your DOE software. So we will go through into few example lah. I think we have 3 example in here. Then we can run through the cases. First on the single factor experiment, multiple levels. Secondly on full factorial design. Third on the fractional factorial. So we also touch on residual when interpreting the result. Experiments involving continuous factors and responses will be covered more in the responsive phase methodology or RSM. Maybe tomorrow Mr. Yazid at the back we will cover on the RSM tomorrow morning as part of the DOE course. Next is Jim, RSM and what?
Integration in RSM in the morning. In the afternoon, the AI.
Okay. In the afternoon, AI lah. AI. Okay. So tomorrow morning on RSM and linear regression lah. Okay. Next. So this is single factor experiment. So for the simple factor 2 levels, a spreadsheet or like Excel can be used because it's simple experiment. However, for more complicated experiment, we cannot use Excel. That's why we are recommending to use DOE software. It can be this design expert or other kind of software available in the market. In this case, because we Petronas already have license for DOE design expert, then our trainers is using this DOE software. But for the participant, is able to use maybe this free trial version for 14 days. But later on, if you want to use this software, maybe the department can request to obtain this software in the department. Okay, for the next sample, single factor 5 levels to demonstrate in the design expert. This one is version 12. So So what is the newest version just now you installed? Is it 13 or 14?
Trial version.
Yeah, version huh? Version berapa ni?
They change it. They no longer call it design expert. Now it's Studies 360.
That is 360. Okay.
Even our the one we have in our department pun is Studies rather than design expert.
Okay. Right. Thank you. So this one is the previous slide lah, actually. So in the laboratory, this is the example lah. In the laboratory, there are equipment requires battery as the power source. So the battery is obtained from 5 different suppliers. Let's say supplier A, B, C, D, E. So maybe Eveready or Energizer or something. So there are 5 suppliers to supply these batteries. The lab researcher wants to check whether the quality of battery for each supplier is similar. So this hypothesis, the first hypothesis is not is all batteries is equal, right? So if you want to another H1, the null hypothesis, the hypothesis H1, not all batteries are the same. So maybe one battery is different, right? So in this case, we have 5 supplier. Okay, we will model this experiment using design expert. Okay, you can open the design expert model. So maybe you can follow it, but step by step. In the sidebar, you can click this new design. I think this one is on version 12. You can click new design, and then after that, in the sidebar, standard design, factorial, randomize. Choose multi-level category. This is also known as general factorial design. Okay, next slide. Okay, in here. So in here you select multi-level category, and then you fill up name supplier, and then put the nominal type 5, level 5, because we have 5 supplier, and then put A, B, C, D, E as the factors. Got it? Got it? Habis? Okay, good. Boleh. Okay. After that, click next. Click next and put number responses as 1 and rename it battery as battery life. Response as battery life. So we want to see the battery life. Is it similar or different? So there's an optional power calculation in the setup screen to detect the effects of the factors. It is recommended to keep the power above 80%. Why 80%? I think this morning apa nama Boon and ada ni Tyrus they explain on this why 80% on the P value. Tak ada. Oh, tak ada. So this is going to reduce the number of errors. Okay. So if we cannot get less than 80%, so what we can do is these 3 things. We can increase the replicates or number of runs, or secondly increasing the delta from 2 maybe to 2.5. Increasing the alpha, but be careful, will increase the type 1 of error as well. If you increase the alpha, you can complete the design by clicking next and finish. However, if you want to get recommended value power above 80%, you can change the delta, which is option number 2 to 2.5 before clicking next and finish. Okay, in here, if you put the battery life here, response 1, horizontal, and battery life, put 2.5. And click next and finish. And what numbers that you can get for for the power, how many percent? You get 80% or you get less than 80? You can get this one name is battery life. Battery life. Oh, this one you have advanced. Multi-level category. Oh, tadi back of back. Ya, ini first. Tadi first is battery supplier. Supplier ada 5 level, so 5 factors, so 3, 5. Oh, dia tak tahu eh? Sekejap. Power not defined.
Maybe the new version it like bypasses that power calculation.
Dia residual tu kan? Dia kata warning, power not defined when the residual decrease of freedom is 0.
You select 5 replicas.
5 replicas.
If you don't have any replication, then you can't calculate the p-value, so you cannot get the residual. Okay, the response.
It's 5 levels and also 5 replicates.
5 replicates, yes.
But also 5 levels.
5 levels. So in total 25. Boleh dapat 81 okey. 81. Oh tadi you tak buat 5 replicates. Tadi ini boleh baik. 5 replicates. How much power you get? Oh, that's good. Because our target is more than 80%.
I see.
Huh?
Slides.
Slide. Later. Okay,
I've already I've sent the experimental data in Teams, so you can copy from that Excel sheet unless you want to type manually lah the results.
Okay, thank you. Jay already share some data in the Teams, so you can copy paste later on and then paste in the software, the DOE software. Okay, if all of you get 81% and more, at 81.5%, and you can click finish. If some of you yes. 5. Okay, you can get good. So your power is 81.5.
So
power dia
let's say dah jadi dia dapat lebih like
51%, 2.5. Power saja. So let's say you run 2.3. So 60%. So if you change the delta power to 2.0 instead of 2.5, you can get 60.1%, right? 60.1%. It indicates a red font, meaning it's not the power is not good. Jay, anything to add?
Right. So basically, just to recap, this experiment is to test. You have batteries from 5 different vendors. So you want to test whether the quality of the batteries are all the same or whether one is better than the rest. So that is the reason why you do this experiment. When you set up the experiment in Design Expert, the power refers to the ability of that experiment to detect whether one supplier is better than the other or not. So if your power is low, even though in reality maybe one vendor has a higher quality battery life, you will not be able to detect it. So you need to ensure that your design has a higher power so that you can detect this result from your experimental data. That is the meaning behind power in Design Expert or in DOE in general.
Okay, thank you, Jay.
Okay. Any questions so far? Okay, next. 7. Now we will let the design expert software to design an experiment for us. So we will have 5 supplier and 5 replication. So in total we have 25 experiment to be done. So we can click the, because here we click the right click on the standard. You can select as sort ascending. Sort ascending. So these numbers become in order from 1 until 25 experiment. But if you do the original runs, you have to follow this the running sequence actually, because the number of runnings, the actual runnings will be randomized. It will not be the same from one to another lah. From like weight and tires is different standard run. So in this case, we want to copy and paste. Maybe I think Yasid already shared the result already, right? In the tips, you can copy and paste in this column. In the response 1 or battery life.
Make sure you sort by ascending order for the standard before you paste.
So if you see, this one is not sort ascending yet. So the run is according to this, but standard is not ascending. So you right click on the standard and then click sort ascending. So after click sort ascending, it will become like this. So the numbers will be in orders, and then factor 1, and then you can click fill up the response. Response like this. So standard runs and also battery life should be similar, all of you. This one. Okay? Any problem? Okay. Done? Okay. Our analysis, our hypothesis has 0. New one until is this similar. Most of the supplier is similar. Battery is same, have same performance. But our H1, at least one bit is different. At least one battery is different, right? So which one is correct? So to analyze the result, we can go to analysis. We can go to the analysis. This one is that, and then on the left sidebar, you can choose response R1. Battery life analyze. You can choose this one, analyze, and then you can see the effect on the tab. If you click,
in the new version of the software, you need to select a transformation first. So in this case, you choose no transform, that's a default option, and then you click start analysis.
So in this case, in the normal plot, you can see all in all plot is on the one on the line, the red line, and only a supplier is having outside of the red line. So meaning that the supply effect factors have significant call that significant significant apa je? Insignificant to the model lah. Right? To the result. So meaning that our supplier is not the same. So we can see in the analysis if you see in the ANOVA tab, next tab after the effect tabs, you can see the p-value is less than 0.0001, meaning the model is significant. Boleh? Okay, the F-test done, some error, okay. Number of the F-value, F-value 14.7, this corresponds to less than 0.01, meaning the model is significant. So this means supply effect is significant. You see the A supply just now in the half plot model, and is significant, meaning that there are differences between the 5 supplier. So we reject the S0 lah. Okay, so far understand? Kalau if you don't understand, we can raise a hand question. You can click one, you can click that. Also start analysis. Start analysis. Dia dua half normal plot. Okay, there's a chance to S0 is true, or supply is the same, but the results happen by chance. But the probability of that happening is of course less than 0.01%, right? Okay, this one single factor 5 levels. There are several assumptions. Each residual must be independent, must have constant variance, and must be normal. To confirm this assumption, you need to check residual plots, and this can be found in the diagnostic tab. You can click diagnostic tab, and then you can have some graph lah. This graph can be used later on when you present, or when you present to your boss lah later on. So even though you are making 25 experiment, but you can tell anything. So this is the normality assumption. You can click the analysis tab, normal plot, like this one. So you can see if the normal plot residual on top of the normal line, that will be okay. That will be good. Okay, you can click also another one for constant variance, residual versus predicted. So in here, you can see if there is a clear difference between the variance, then transformation will be needed. And to apply transformation, you can go to the transformation tab. So in here, we don't see any pattern. Let's say if there is any pattern, that one line in here at the left and then one line at the on the right. So we may need to have some transformation for this model. So in this case, it's randomized. we don't need transformation. This one also residual versus run stability assumption. If the plot is randomized like this, okay, but sometimes there are some numbers in outliers. Outliers is beyond this two red line, outside of the red line. Then these are the number of red line outliers. Then we need to do some transformation as well. With no clear pattern, okay. Okay, so far that's the multi-level factorial. Any questions so far? If not, we continue to full factorial design. Jay, anything to add?
Just to add a bit, because earlier on, when you created your test matrix in Design Expert, and then you key in the results, when you analyze the results, the ANOVA tag will tell you what the model is based on your experimental data. So, what some people might do is they just take the ANOVA results, get the model, and then finish. But that's actually not recommended. The reason why we go that extra step of checking the residuals is because when Design Expert or any software calculates the ANOVA, they use some statistical methods, and these statistics have some assumptions. So you check the residuals in order to check that the assumptions are not violated lah. Because otherwise, if the assumptions are actually violated, then the results will actually not be valid. So that is why even after you finish your analysis, you get your ANOVA, you get your model equation, you need to check the residuals to see that they're all okay.
Thank you, Jay. So just a reminder to check the residual, even though after you obtain the results later on. Okay, we move on to full factorial design. Okay. So full factorial design has k number of factors and two levels. This experiment design very useful to screen a large number of factors. For example, 2 to the power of 3 factorial experiment has 3 factors, 2 levels for each factor, and 8 total treatment combination. 2 times 2 times 2. So a full factorial design need to be replicated so that there is enough degree of freedom for the error estimation. Otherwise, we will not be able to conduct statistical tests.
Fadhli, we need something.
Yeah. Which one?
Previous exercise, which is the best battery supplier?
Yeah. Other question. So I forgot to ask you. So from this experiment,
Because the whole point of the experiment is to find which is the best battery vendor, basically. So in the end, you need to be able to answer that question.
so which one is the best battery vendor? Supplier A, B, C, D or E? Huh? Where you can find it? The best supplier?
Ada hadiah ke untuk dia?
Tak lupa dia. Ada hadiahnya. Siapa?
I think sebab dia ada longest memory card.
D. D. If you see 25 hours 25, 19, 22, 19, 23.
Well, you're supposed to let the software determine the results. It's just algorithm.
So
Yeah, isn't it? It's one of the main.
yes. In here. 21.6.
Correct.
Correct.
Yeah. One way you can check is to look at the means of each supplier. So you can see supplier D has the highest average battery life, basically at 21.6 hours. Another way you can check for those who are more visually inclined, you can go to model graphs, and there is a graph of battery life versus supplier. So that one you can also see that D is much higher than the rest when it comes to the battery life.
So you can open the model graph, and then you see the plot. Model graph. This one. This one here. This is the highest. So dah dapat tak semua? Okay. Okay, shall we continue? Maybe for full factorial. So this is some exercise. I think how about if you can try this exercise first? By your own? Is it okay? So in here, a researcher wants to investigate the factor that affect the conversion of a chemical reaction in a lab scale reactor. Okay, the conversion is defined as the percentage of reactant that has been converted to products. So this is some kind of a process reaction lah. And then he wants to know whether the following factors have an effect of the conversion: pressure, temperature, and residence time. So these are the three factors. And then he run the 2 to power of 3 full factorial with 2 replication, totaling 16 runs. So these are the setting. Temperature low is 100 degree to high 200 degrees, and pressure 30 bar and 50 bars. Residence time 600 seconds and also 1200 seconds. So you can open your design expert software and then select this full factorial 2 to the power of 3, and then you can select you can fill up the information on the factors and setting of low and high. results ni kita nak percentage of conversion of chemical. Okay, so how about you? Oh, you just select this one. Blocking.
I shouldn't.
You shouldn't select.
Okay.
Blocking normally, if you have maybe 24 hours, let's say, so we want to block maybe day and night
I see.
experiment. So we need another experiment on that.
But then, so blocks must be one.
One. Okay. Percent of conversion. Blocking maintain one, eh? We have to change blocking. 5%. So we get 95% power.
Okay.
Boleh share dengan ni you kena change tu lah. Low tu 100. Masukkan put the value lah. Put the value. Okay, I will continue lah. Okay, this is very open, and then you can select regular level, 2 level, and select replicate screw because screw replication, and then select this total count of 3 for full bacterial, and then click next, and then you fill up all the info, change the temperature, pressure, and distance time, and then put low and high, 100 to 200, and also 6, and then click next and finish. And then put this the response conversion of units in percentage, and then click next, and then you can get model power of the 95.6%. Okay, this is above 80%, so the model is good. Okay, this is the results. Results you can find also in Teams. You can copy and paste, but don't forget to sort assembly on the standard run. This one, sort assembly, and then you can key in the number. This response one conversion percent. Then we can analyze the data. Okay. So far okay. After you key in the results, dah dapat. Belum lagi. Ini tak copy paste. Finish. Okay. Key in the response percent from the views. result you can get from the experiment, the real experiment you have conducted in the lab. So in this case, because we have already obtained the results from the lab, so we just give it to you. So no need to take time to. Okay, after you key in the results, and then you can click the analysis, analyze the results. Choose R1 conversion and the left sidebar, on your left sidebar. So for now, let's choose the transformation and go to the effects tab. So from there you can see, you can select the factor that is not falls into the half normal plot line, the red line. So you can select this factor A, B, C, AB, BC, ABC. Huh? Effects because
Start analysis first.
start analyze and then click effects. Dapat tak?
They have the variable plots at my side. In the old version, it's just the half nominal only lah. You have three factors. That one seems to be three factors. Yes, in fact, I suspect this should get some Chinese person. This is the two-level factorial. Multi-level is more generic. By right, you should be able to understand. You just need yes.
Some of you will choose multi-level, so the result will be different. Okay. Oh, you are so
Actually, this selected by the yeah, because it's two level and three factors. So three factors is 2 by 2.
Okay. So in the ANOVA shows that the model is significant. If you see the p-value less than 0.0001, so it can be described that experiment results at least one of the factors have an effect to the response. So for the p-values, if you see the factors A, B, C are significant, as well as AB and BC. So you see the numbers on the p-value, if less than 0.001, meaning that the factors is significant, so have some effect to the results. So if you see AC and ABC is not less than 0.001, so meaning that the factor is not AC and ABC are not found to be significant. Okay. So again, like Jay mentioned just now, you can see the for complete the analysis, you see the residual plot. Is there any issue? Ada issue tak? If you see in the plot. So no trending, no outliers. Outliers will reside above this red line, and no trending. The dot is not at the one single line, something, and randomly, and then there's a plot at the dot is on top of the red line. Okay. This way, okay. Any question? Tak ada. Kita tak tahu. So we continue a bit on the fractional factorial. Tadi just now we have finished multi-level factorial and then full factorial. Now we have fractional. Why we do some fractional factorial? Anybody knows? Apa? Okay.
Reduce the number of experiments.
Good. Yes, correct. So normally, if 2 to the power of 3, we have 8 experiment. If we do some replication to increase the p-value, we can have 16 numbers of experiment, right? So for fractional factorial, we can reduce the number of experiment, but maintaining the power and the level, the model. So the model still significant if we want to proceed forward, but numbers of experiments is reduced, let's say from 16 numbers of experiment down to 8 number of experiment. So it saves time and save cost as well. So for this case, normally we have like 2 factors or 4 runs for full factorial, and 6 factors we have 64 runs, right? So this is the number. 2 is the number of levels. 5 minus 1 meaning that factors, but we use 2 or 4 because 5 minus 1. D is the resolution 5 design. So we have another exercise in here. So because I think we don't have much time, so I think we just go through lah this one. No need to do. So in this exercise, this researcher investigate the effects of several factors, influence in growth rate of certain noble metal soft crystal in the laboratory. The following factors are investigated: 5 factors: temperature, pressure, crystal amount, stirring rate, and cell volume. So since the number of runs for full factorial is large, the researcher decided on resolution 5 fractional factorial with 16 total of runs. Okay. So this one 2 to the power of 5. So this is the factors, 5 factors. So 2 to the power of 5. By right, we should run maybe 32 runs. Instead of that, we can go to the power of 4. So 16 runs only. So this is low at night. What we can do is open new design. Okay, just click in here. Instead of 2 to the power of 4, 4 minus 1 is still 3, right? Okay, I think this one is step by step, and then you can get this randomized standard one and fill in the response time. So also share in the tips. So similar to the full fractional factorial just now, to analyze the result, we can see the normal plot and the half normal plot. Basically, all the factors decide on the red line, but there's some. If you see a normal plot, there's 3 factors: A, D, and stir rate have some significant value. So maybe this can have most influential factors to the experiment just now. So you can go to the next step. Okay, from the normal plot you can see the ANOVA tab. Go to the ANOVA tab and then see the significant p-value. So A check the residual as well. Okay, next residual. So in here you can see just now you can get a good residual value, but now the residual doesn't still fall into the normal line, the red line. See, and then in here you can see the various of residuals seem to be widely different. There are some dot over there and one single line in here, not similar like the previous one, the full factorial. And then in here you have some outliers. This the blue one outside of the red line. So this one the outliers. So what you can do, you have to do some transformation. So transformation, how you can go back to the transform tab and select natural log transformation. You can select here transform and natural log, and it will have you can have no new half normal plot, and then you can select A and B. You can select that A and B, and then the ANOVA results indicate the model is significant. Temperature and stir rate have impact on the growth rate. Okay, and then you need to check again the residual after you do this transformation. So after you do transformation, since the residual plot is okay and no outliers, the residual also have some randomly distributed. Also here, okay. So if you don't get the good residual, then you need to do some transformation. That's how we can do the transformation just now. Okay. So far, any question? If not, maybe we can take a break. After this, we want to have last exercise for the helicopter view, so helicopter flying time for real experiment. So we can cut the paper to make a helicopter, and then we measure the flying time. We can divide into two groups.
Apa beza warna-warna?
Warna red, yellow and green is actually the resolution. Red is resolution 3, yellow is resolution 4, and green is resolution 5.
So what?
Normally best to have the green punya resolution. With one main factor and 4 interaction lah kalau resolution 5. I think this morning pun ada cerita pasal resolution. Not yet. Okay. In resolution 4 maybe 1 main factor and 3 interaction or 2 by 2 interaction. Okay. Any more question? Yeah. Salah yang di luar peradaban. Kita nak tengok ini signifikan atau tak signifikan. Dia tak masuk. Kalau model interest A, B, A, C atau B, C 16 dan 0.01, maknanya model tu signifikan. Maknanya dia ada effect to the experiment. Okay, any question? If not, maybe we can take a short break, maybe 10 minutes. After that, we regroup, maybe at 4 PM. And then the last exercise for today. Okay, thank you. straight line. Kemudian dot tu dia satu dot dia ada banyak data. That one kita kena buat some definition. Kalau dia render berapa semua atau okay. Ada outliers atau okay. Yes, dia soalan saya
Dinamik ni dalam walaupun dia saya.
Normally we students bagi mampu apa kata dia kalau kita time
Is it off?
too many
Is it there?
experiment so we select grade 1 so -1 ni actually the maximum criteria so instead of you had let's say today 5 meter by 2 runs now you can get to power 4 maybe 5 -1 so you can only have 16 runs instead of 32 runs so that's the benefit lah so you jimat the time and then the cost of the experiment so normally we can get choose the green one as also 5 certain 4 that's fine certain 4 and 5 this one 3 so 3 normally you don't use
Sleepy. Very sleepy today.
bagi grup kan grup mana grup
Saja dia tree dia tak benar apa. Beli dia tree. Apa tree itu sudah ada tree. Nah, anak aku. Tree dekat dengan dia lain masih. Panas sebenarnya. Pupuk. Ini cuma ada mana? Okay, ini. Mesti dia bilang buat dia ini. Lakon tak perform. Kau tak mana? Dia pakai sini tu. Tak grafik. Manual. Jadi I bisa kan. Ada kira manual. Manual. Ada tu kira dia punya apa ni significant factor dia sama dia punya
last exercise for today. For DOE, we have some helicopter flight time. So we will design a paper helicopter by using this paper. So we cut all the so you can get this kind of shape, and then we can measure the flight time. So we have minimum and maximum level just now, according to maybe the wings of the helicopter, and then you do take some time lah. Okay, like this lah. So we try again. So we measure how many seconds. Good. Okay. So if you see this helicopter, what are the factors of that we can see from the helicopter? What is the factor? If you want to go from like KL to Malacca, so what will be your response? Is it flying time or what? The fastest or what is normally the factor? Maybe you can see the blade, maybe the wings, maybe the weight of the helicopter. If more weight, maybe less. More weight, maybe speed. So in this case, maybe we can have 4 factor and 1 response. We can divide into 2 group or 2 block and 2 replication. We will run DOE, include all the factor, level and results, and perform ANOVA analysis. So this is the factor and level. Maybe first is the clip, 1 clip or 2 clip. You can have the paper clip in here. So you just attach paper clip at the bottom of the paper. Body line actually the body line from this top to bottom, and then body wing length is the top length. Body width D is this one. Okay, this is the level, and then we have this one. Sorry, body length is B. Body length is B. B from this dotted line to bottom. Wing length is C from the top to bottom, and to the dotted line. And then D is the body width. D is body width. This one is paper clip at the bottom. Okay, after that you run experiment. So now we will divide you in 2 groups. Maybe we just a random number lah, maybe 1, 2, 1, 2. Start with who? Maybe Darius. 1, 2. Ini ya. 1, 2, 2. 1, 2. Gitulah. Jin apa ya? 1, 2, 1, 2, 2. Okay. Maybe group 1 over here, group 2 over here. Is okay? Okay, this one last experiment that we will have to do. So we will have to do this design of experiment. Make to replicate. Okay, group 1 and group 2. Maybe you can just regroup for easier. Okay, now we will have these two groups and then make a design response to level, and then in total we will have about 16 experiments. So each group have 16. So 8 in this one. This one 8. Maybe one person key into the result in the year. 3, 4.
Thrill. That's a thrill.
This one for high level. We have 2 level. Lower and high level.
Record your own session tomorrow. Okay, but you need to buy the SD card inside the memory inside. No, I was thinking that if you use Microsoft Teams to record the session video, and later when you can just record the MS Team.
Yes.
But you can have external camera kan.
Just
But the memory juga kan.
make like this, and then put the paper clip, one paper clip, and then you measure the flight time.
Can we take more than one pizza? Because you get only one. Can we take more than one?
So another one. This one the high level, low level. So you have 16 runs lah. So this was. Seorang buat ni lah kot. Ada begini ada. So yang ni low level, yang ni high level lah. Okay. jadi pilot lah, kalau jadi pilot kena make sure the same punya height lah. Line ni senang sikit. Kalau rendah sana nanti tak nampak difference dia. Nanti kena tinggi sikit.
Yeah, so 2 paper clip and 1 paper clip, run 4 and run 6. Yes,
Nanti
change the rate. Run 4. Run 6 ada kan?
boleh tanya, kita nak tulis nanti.
Boleh tak?
Siapa nak naik kan? Kita nak berapa dia pergi? Kita dia nak tulis kan?
So, one of you must be a pilot. Select the pilot. And then like maybe same level like them. This level. Kena same person, should be same person. Okay. One of you take time. The flying time.
Okay, we'll start with this.
Yes, run 4 and run 6. You proceed. Check this out.
Yang lain tu ada. Dia kata cukup lah.
The line is this is the line. Good. Dia punya height tu sama. Kena sama. Yang tu tambah.
That was run 4.
Kurang.
Oh, tak aci. Oh, logik lah. 150 is lower.
Pakai harness tak? Diorang perlu pakai harness tak? Working at height.
Less than 2 meters.
Okay eh?
The size is 130, 80, 30. Yang kecil, 90, 100, 30. I think that one. Apa, mesti thank you. Yang ni is 50. So 90, 80, 50.
Takut dia lain-lain saya. Sama.
Kecil tak? So that one is 90, 80, 50. One application. One application. Okay, go pilot. 1, 2, 3. Salah landing. Salah landing. Okay, 1, 2, 3. This, I think it's error in taking off.
But this clip doesn't make
Doesn't fit. Doesn't fit. Doesn't fit. 90, 100.
Okay, let's go.
Okay. 1, 2, 3, 50. 90, 100.
Ada tak sampai follow this but if you run
1, 2, 3.
I've stopped.
1, 2, 3.
Yes. Repeat once. Better?
Better lah, it should be slower, it should be slower than the kan. Yes, 150. Yes? Yes. 130, 150. Ah, you have it ready. We can select. I see your launching technique has improved.
Yeah. It's been better. Yang tadi ada Yes.
Tadi dia punya wing dia Satu, dah tinggi tu, satu. Dah siap ke?
Pilot je tahu.
This sebab apa tak sebab dia ada aircon tu. Aircon tu shit down further. Noise. Ada. Untuk Syarul. Syarul betul-betul berat.
Sono lagi. Sono ni.
Kat rumah boring.
Datang juga.
Last one.
Alright. 1, 2, 3.
Boleh sih. Okay, bye korang. Boleh bawa balik lah ni. Main tanah. Jadi, present seorang tu. Pas kita belajar. Question sama ni.
Cik, kau lagi banyak. Banyak lagi kata siap tu. Sebelah banyak lagi kata siap. Sebelah tak siap ke?
Ni apa ni? Shopping.
Tapi jawapan kita tak tahu which one is the optimum, kita tak ada.
Tree. Boleh je beli kat kedai, bukan mahal sangat pun. Tapi tree dapat tu.
78. 78. Faham.
Aku ni kau dah dapat email tu, aku dah email tu. Pasal yang kau punya approve dengan endorse itu kan? Apa yang aku dah hantar email tu aku betulkan tu. Tapi kalau kau ada yang words punya copy, kau tu words copy tak sebelum yang kau hantar dengan DC tu dalam PDF word. Sebab dia table tak apa yang itu betul semua. Kau kena terbalik ke atas ke bawah dua table tu. CEO dan VC approve lah. Yang endorse tu bukan CEO. Bukan VC kan. Juga VC kau sangat dia. Aduh. Dia nak dia yang approve lah. Dia tak boleh endorse. Tak ada juga. Yang kau cuk.
Tapi every group akan dapat
Okey. Terus sekarang kita dah
interaction tak sama.
kat pergi tanda tu.
Something adalah sebab kita nak tahu
Aku dah tahu kau tak boleh.
interaction yang akan
Aku hantar kat diri aku sendiri. Aku hantar email kat diri aku sendiri. Apa? Tak, aku hantar email kat diri aku sendiri.
dari interaction body dengan clip. So
Dapat tak? Dapat?
Dia makin berat.
Okay, kau tengok
jadi
yang content it should be endorsed by program head. University. Tapi university Datuk Doktor ni kan vice. Macam mana pula vice chancellor kau yang endorse, lepas tu deputy vice chancellor approve.
1 second and 1 clip. Dan
Allah.
kita tak ada
Tak ini dah luar. Ya. Sebab dia dah sangat dah. Kalau kau lah kau terbalik. Ya, so sekarang ni Ya. So kau kena bawa kan table yang 4.0 tu yang royalty, 3.0 tu yang Fauziah.
So that's the promotion lah. So kalau nak ni kalau
Sat table kau tak dapat. So yang approve tu sebenarnya 2 orang je. Yang endorse dia ramai orang, 4 orang.
tambah satu lagi akan tengok sini ataupun nak kurangkan.
Tak apa yang sekarang ni. Sebelum aku nak bagi dia WhatsApp, aku kena dah betul orang kan buat mesej aku tanya kan mati kau jawab.
Ataupun
Kan?
kurangkan punya kurangkan lagi jadi ataskan.
Tak, aku rasa gini kan. Kau terbalikkan table tu je tak apa. Kau yang PM ni dah sayang dua. Tak ada hal lah kot. Dia sebenarnya benda tu kan.
Itu benda kau.
Tak tahu. Yang Hayati tu sebenarnya kau perlukan nombor 4. Yang Fauzia tu nombor 3. Kau faham tak? Kau punya yang approve dengan endorse tu, kau punya yang kau hantar aku tu dia terbalik tau. Kau kena terbalikkan nombor 3 dengan nombor 4. Kau terbalikkan table tu aja. Boleh je kau ada yang words tu. Boleh kau boleh paste balik dekat PDF tu sebab sebenarnya ya tak kau ada words tak? Words yang last ni. Okay, kau guna words tu dulu. Mana kau guna words tu dulu. Lepas tu kau kau terbalik situ. Lepas tu kau boleh daripada PowerPoint presentation kau boleh cut and paste dia punya tu je apa. Kau bagi je aku words, nanti aku buat kan. Tak, kau bagi words yang tak ada sign dulu. Nanti aku tolongkan. Nanti tapi kau email balik kat aku dulu. Faham? Kau bagi yang words kat aku sekarang. Okay? Sekarang tau sebab aku masa ni aku nak buat sebab esok aku takut tak sempat dah sebab susah aku dah. Buat hantar sekarang yang words. Okay, terima kasih.
So Google ada
Yeah, alright. Okay, bye.
Apa saya tadi bercakap dulu? So both group already obtained the result. So which one have the more flying time? One clip maybe. Less body weight and body width and with less or more wings, wing length. Okay, after you obtain the result, go to analysis and then select all the factors in the normal plot. You should get this one, and then check for the ANOVA analysis. You should get this p-value less than 0.001 is the significant factor used. But some of you, I think both group doesn't get this p-value, right? I'm not sure, maybe some error during the testing. And then this is referring to the evaluation, the response. This is diagnostic that you can see. Select the normal plot, residual, and also this one, box counts and distance. I think don't need to look into this tool at this moment. So for this residual, you don't see any scattered, you don't see any pattern. And then the residual versus run, no outliers that you can see, all inside the red line. And then this is also scattered. Compare the predicted model versus actual. So scattered. And in the interaction, you can get this should be. So this is the interaction between flight time, time of second in not in mm, second, and clip. So the more clip, to clip is having less flight time, right? Because more weight. And then this is the interaction between B80 and B100. So the body weight 80 and 100, meaning that more. Sorry. B100, B80.
Longer body, more weight.
All of the body more weight. Okay, good. So this means that the black one is at the below lah. move it. So you can adjust, and then on the left side, on the right side, you can adjust. So you can see what is the affected factors in the model. So upon on this experiment, you can see what do you want. If you want less flying time, maybe you can extend further, 3 clips or 4 clips. And then if you want less flying time, maybe you can have more lightweight of helicopter, right? Okay, there's the contour. This is the 3D model that you can see. You can click contour in here. Okay, maybe that's all. So the 5 p.m. Okay, as a summary, what we have learned today, we have learned design of experiment model, touched about the methodology of DOE, factors, levels, and responses. Also the replication, blocking where we have day and night, we shift different personnel, the night personnel and day personnel may be different. And then software introduction of design expert software. We have conduct 3 exercises, including 1 helicopter exercise on DOE and application. As a review outcome, by now learners should be able to understand the DOE model, the single factors, full factorial and fractional factorial experiment. Yeah, able to utilize design expert software properly. And then lastly, apply the design expert software for given case study for helicopter flight time. Maybe without referring to manuals, so you can do by your own, right? If you have any question, maybe just let me know. Last one, any question? Before we end the session.
There's no interaction. How can you see the interaction for the wingspan?
Wingspan tadi kita ada 130, 180. Mungkin at this time doesn't have any effect. Masa you run ini, the results obtained in the experiment, it doesn't show that the wingspan doesn't have any effect. It's testing.
Yes. It doesn't have any effect.
Yes. In the model they given. Good question. Should be if you buy a fan or something, the wing length should be have more more effect lah kan. Maybe during the experiment, that's the result you can get.
This one model we use linear model.
Yes, linear. Okay. So, any more question? On the floor? If not, we call it a day. We continue tomorrow, maybe 9 a.m. We will continue on RSN and also linear regression by Yazid, followed by AI in the afternoon by Shazwan and Asmin. Okay, thank you very much and have a good day. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you.